Okay, so today in our first lecture, we're going to talk about straight lines. You will see that this course will use the name or the term line or linear quite often, because this course essentially is a incursion, if you want, through mathematical topics that deal more or less with linear formats for the algebraic equations that represent some of the tools we will learn. There will be some stuff that is not strictly related to lines or to linear forms. For example, we're going to talk about probabilities later on. But a good portion of the course will use this terminology. We'll talk about later how a linear form looks like. But if we use one or two variables, there are geometric representations of these linear forms. And I should say that most of you probably know this stuff already. Just for the sake of completeness of the course, we will go step by step with all necessary prerequisites or requirements before we proceed. So for example, today we will talk about the equation of a line. So that's one of the main goals for the lesson today. And then how to obtain the equation of a line given some information like the slope or a point or the intercept of the line and so on and so forth. So I'm expecting that many of you know this already, but as I said, for the sake of completion, we will go through all the definitions necessary. And obviously go through the homework as soon as possible, even if you know the topic already. So before we actually, and by the way, straight lines in terms of geometry is one of those things which are not really strictly defined except via algebraic equations, but from the point of view of defining the figure, we assume that everybody knows what we're talking about. So here's a vertical line, here's a slanted line, a horizontal line, and so on and so forth. So we know what a straight line means from a geometric perspective. Let's see how we define the equation of a line, or what we mean by the equation of a figure in general. So for that we need the familiar coordinate system, in which if we talk about figures that can be represented in the plane, then all the points on that figure are identified by two coordinates. So in this case, let's denote them by A and B. By A, we mean the distance from the point to the y-axis, and by B, the distance from the x-axis over the y-axis. We always specify the x-coordinate first, and the y-coordinate later, or second, by convention. So as an example, let's say I want to represent the point of coordinates 2 and 3. Then in my coordinate system, I measure 2 units on the positive side, 1 and 2, and then 3 units on the positive side over the y-axis, and then draw the lines parallel to the axis, and that's the point of coordinates 2 and 3. By the way, in this class, we're not going to be that picky to count or to mark the grid precisely, especially if we use bigger numbers. All it matters is to label the points correctly. I mean, in other words, to label the points in such a way that it makes sense in relation to other points. So let me give you a quick example. Let's say I want to sketch the points of coordinates 2 and 10 and the points of coordinates 5 and 1. We don't have to count the units, just label them and make some guesses with respect to how big one piece should be with respect to the other. So for example, let's say this is 2 over the x-axis and somewhere here is 10. So I don't have to count 10 units, I just label it by 10, and I just have to make it obviously bigger than this segment, right? Because it's 5 times bigger. But you don't really have to make it 5 times. We don't have to be that picky, in other words. So this is the point 2, 10, and then 5, 1, of course, will be a little bit here. Let's say this is 5, well, and then this is 1. So this might seem messy to some of you because, for example, it looks like 5 is it's kind of, the same length as 10. I should have made it obviously bigger, right, this one, but that's not important. So I want to emphasize that we're not going to be focused too much on whether this segment is really twice as this, right? All that matters is to label the points if necessary and put them in the figure in such a way that the picture looks helpful. What is an equation of a line? So before we move on to this topic, let me just mention that the equation, as a general definition, the equation of a figure doesn't have to be a line. It could be a circle, a plane, and so on. So the equation of a geometric figure is nothing but the algebraic relationship between the x and y coordinates. I got bumped there. So between the x and y coordinates of that figure. So it's an algebraic description of x and y. Now, notice that I should say here the equation of a, let me actually add a little bit of word here, of a planar figure, right? Because, for example, if we have a figure in three-dimensional space, so a three-dimensional object, obviously we have three coordinates, x, y, and z. And if we want to go fancier than that, we can, use any number of dimensions. But, for this particular example, if we talk about planar figures, the figures in the plane, the equation of any figure is essentially a description, an algebraic description of that figure using the x and y coordinates. So in other words, all the points on that figure should satisfy that equation. Which brings us to the familiar equation of a line. And there are multiple ways to write the same thing in this case. So for instance, one of the more general formats for the equation of a line is ax plus by equals c, where a, b, and c are known numbers or known coefficients. So as an example, if we have any expression of that form, let's say minus 2x plus 7y equals 1, this is obviously a line. And when we say a linear form, we mean any expressions of that type. And let me mention here at this point, linear expressions in general, not just in two dimensions, are essentially combinations of this type. If you look at the entire expression, doesn't matter where it's placed, left, right, and doesn't matter how you rearrange it, it's essentially a summation of terms that contain a known coefficient, a real number, times a variable. In this case, just two variables, x and y. Whether I move one to the left and keep 0 on the right, or get it in terms of y by itself, as we often do, that's just basically equivalent statement of the same, or equivalent form of the same thing. So that's one of the format of the equation. A far more useful one is the so-called slope-intercept form, which is the same thing but with y on the left-hand side. So if we rewrite this equation and leave y on the left-hand side, and let's just the coefficients by mx plus b, that's one of the most useful format for the equation of a line. It's useful because there is an interpretation of this coefficient of x, namely the slope of that line. So for my example here, if I want to write it in the slope-intercept form, I'll have to move 2x on the right-hand side, so 7y equals 1 plus 2x, divide by 7 both sides, and then we have y equals 2 over 7 times x plus 1 over 7. By the way, as we move along with this class, anybody watching this, if you notice a typo, they occasionally happen, and if the typos are small enough, it's not practical to redo the video. And I would prefer to basically make a correction in the comments. You'll basically, if the video has a pinned comment, make sure you read it because it's a correction of a possible typo that I will notice later. So that's an example of a slope-intercept. Now, what is a slope? From a geometrical point of view, the slope is the tangent of the angle made by the line with the x-axis. So it's a measure of the angle that the line makes with the x-axis. So for example, here we have a positive slope, intuitively it's useful to think of the slope as corresponding to a line that increases from left to right. So the line goes up as you move from left to right. Then we have negative slopes. For a horizontal line, we have zero slope. And for a vertical line, the slope is not defined, as you'll see. Especially if you look at the definition of a slope, the way you compute it, you will see that why the slope of a vertical line is not defined. Okay, so with that being said, let's see how we actually compute the slope of a line. Typically, from a geometrical point of view, in order to identify the line, all we need are 2 points. So if I have 2 points, then we have a straight line. We have a straight line defined, 2 distinct points. So starting with 2 points, let's see how we can compute this quantity. Like I said, the coefficient of x in that form, which will be the slope. And you'll see that b is the intercept, as you'll see on the next page, because that's the y-intercept. I mean, the point that the line intersects with the y-axis. All right, so moving on. Let's see. Trying to figure out how to do the next page. The next page was a little bit delayed. So moving on with the with our topic. So moving on. How do we compute the slope of a line between 2 points, let's say x1, y1, x2, y2. So given 2 points of these coordinates, the slope, which is denoted by m typically, if there's no risk of confusion with other slopes, is just the difference between the y coordinates divided by the difference between the x coordinates. Notice the order of the points matter. Whether you start with the second point or the first point doesn't matter. I mean, you could start with the second point and say the slope is y1 minus y2 over x1 minus x2. But you have to be consistent that when you take the difference of the coordinates, you start with a point on the top and on the bottom. These two are equivalent expressions, so they will give you the same slope. And let's go through an example. So suppose we have a point of coordinates minus 2 and 3 and a point of coordinates 2 and 1. So the slope is, let's start with the second point. So 1 minus 3, the difference of the y coordinates, over 2 minus negative 2. So that leaves us minus 2 on the top over 4, which can be simplified by 2 minus 1 over 2, if we divide by 2. When we have a point on a line, so in this case, let's say we start with the point minus 2, 3, and we know the slope of the line, which we just computed, and in some cases that might be given in the problem, we can compute the equation of the line, the so-called point-intercept form of the equation of a line. So if we have a point, let's write it as a formula. So if we have a point x naught, y naught, and a slope denoted by m, this point-intercept form of the equation of a line is y minus y naught equals the slope m times x minus x naught. So that's one of the other, that's basically the third format of the equation of a line which we discussed in this lecture. And this is what often happens in many applications. You are given the slope, or you can compute the slope from 2 points, as I mentioned here, and then you will pick one of the 2 points and then find the equation of the line using the slope and the point given. So in my particular example here, why not, if I use the the point, like I said, minus 2 and 3. Y naught is 3. The slope is minus 1 over 2. And then we have to pay attention to the signs here, x minus x naught, but x naught is minus 2. So we have a double negative there. Let's clean up a little bit. Y minus 3 is minus 1 over 2 times x plus 2. We can distribute minus 1 over 2. So we have minus x over 2 minus 1 over 2 times 2, which is, let's move 3 over as well. So that makes it 3 minus x over 2, and this is going to be minus 1. And then 3 minus 1 is 2. So in a simplified form, in a slope-intercept form, the equation of this line is minus x over 2 plus 2. It's a good habit to have to write it in the slope-intercept form, because if we need the slope later, it's easy to read. The coefficient of x happens to be the slope. If we sketch it as well, this form also is kind of easy, because the way to sketch it, of course, we pick 2 points and then sketch the line. And you can pick any 2 points, but usually the intercepts are easier to compute. So for example, if I plug in 0 for x, that gives me the point 0, 2. Remember, you always mention the x coordinate first. So x equals 0, y equals 2 over here. Then you can pick any other point. For example, you can plug in any number you want for x. One easy number to plug in is 2. So let's say I plug in 2 for x. And that gives me minus 1 plus 2, which is 1. And that means the other point I picked here is 2, 1. Okay, so x was 2 that I plugged in here, and then y is equal to 1. So 2 and 1, I measure 2 units here, 1 is over here, so the actual point 2, 1 is over here. And this is the sketch of the line. That being said, let's do one more exercise. You will see in the homework a certain type of exercises that emphasize the meaning of this equation of a line, in which you are given the equation of a line and you are asked to plug in various points on a table. The point of this exercise is to make sure we don't confuse the x and the y coordinate and we understand how to compute one when the other one is given. So a typical example is to have a table, like I said, with some of the values given for x and y, and then to compute the other one that's missing. So each column in this little table represents a point on the line. And then your job is to find the other coordinate, the missing coordinate of that point. So for example, if you look at the table here, we have basically 1, 2, 3, 4 points. You're missing the y coordinate on the first point, you're missing the x coordinate on the second point, and so on and so forth. So what are the missing variables? The missing coordinates? Well, obviously, if I want to find the y coordinate of the first point, I'll have to plug in 0 for x into the equation of a line, and that gives me 6. So that's 0, 6, one of the points given here. So it's all about making sure you plug in the correct position and solve for the other. And notice that often you may have to actually move the terms from left and right, which means it's extremely important to be comfortable with basic computations and make sure you practice enough if by some reasons you're not yet. Second example, y equals 0. I need to find x, so I go to the equation here and I replace y with 0, which means to find x I'll have to solve a little equation. I move 3x on the left-hand side, which means I change the sign, and then finally I divide by 3, which gives me x equals 2. Always remember the first coordinate mentioned in the point is 2. So if you have to specify the point you just found, that's 2 and 0. So the missing coordinate in the table is 2. These are, by the way, the so-called intercepts, because these are the points on the x and the y axis. This will be on the y axis, this is the y-intercept, because x is 0. and this is the x-intercept. Excuse me, the x-intercept because y is 0. Let's do the other two examples here. So x equals minus 2, minus 3 times minus 2 plus 6. The coordinate that I get is 12. And finally, on the last one, we replace x with 0, which means, no, sorry about that. Okay, so we replace y with 9, y is given. And that means we solve for x. Move 6 on the left, that means 9 minus 6, which is 3, equals minus 3x, divide by minus 3, that gives me x equals minus 1. And write the answer here. So that's it for today, for this lecture. Again, I am aware that this is very basic stuff and most of you already know that. But even if you know everything on this, just make sure you get used to the mechanics and how we actually go through the course. And if you have any questions or any remarks, let me know. Always remember that I expect you to use the pause button. As you notice here, I don't actually have lots of breaks when I go through the topics, because I want to keep the video as short as possible so that it's not unnecessarily big or large in size. But I do expect you to pause and catch up the computation. So especially when I do these computations quickly, I expect you actually to pause, because you don't want to move on from one step to another until you actually understand each step, how it's done. So that's it for today. I'll see you next time.